Hello students, very good morning. Welcome to Narayana live classes. Today for 9th class students, we are going to discuss assignment number 23 on theory of equations. In particular, these questions are related to change of sign rule, that is Descartes rule of signs. Descartes rule of signs. Okay, now let us see the first question. The number of positive roots of x power 9 plus 4x power 8 minus 2x cube plus 7x plus 8 is equal to 0. How to do it? So here we have given function, let us take as an f of x. That f of x is equal to x power 9 plus 4x power 8 minus 2x cube plus 7x plus 8 is equal to 0. Whenever you are asked to find out number of positive roots, what to do? You have to observe the changes in the signs of the terms of f of x. Changes in the signs of f of x. So what are the signs actually speaking here? It is plus here. Again plus here. It is minus here. It is plus here. It is plus here. These are the signs of the terms. First term has positive sign, second term has positive sign, third term is negative, fourth term is positive, fifth term is positive. Okay, now how many changes we can observe? Plus 2 plus there is no change, but plus 2 minus there is one change, minus 2 plus there is one more change, plus 2 plus there is no change. How many changes are observed here? Only 2 changes are observed. As there are only 2 changes, what we can conclude here is there are at most 2 positive real roots for this f of x is 0. There are at most 2 positive real roots for f of x is equal to 0. At most 2 is nothing but the third option. Okay. Now let us see the next question. The minimum possible complex roots. He is asking complex roots or imaginary roots also we can say. If x power 6 minus 3x power 5 plus 4x cube plus 3x square plus 4 is 0. Let us see the solution. Let us take the given equation as f of x. F of x is x power 6 minus 3x power 5 plus 4x cube plus 3x square plus 4 is equal to 0. Okay, whenever you are asked to find out minimum, see always whenever you are mentioning imaginary roots, that is at least, minimum number will say. Whenever you are representing real roots, maximum will say, that is at most. That is very important here. For real roots we mention at most. For imaginary roots, we mention at least, minimum. For real, at most or maximum. For imaginary, at least or minimum. That is very important thing you have to keep in mind. Anyway, for finding complex roots, first what to do? You have to find out number of positive real roots, then number of negative real roots. After that, we can find out number of imaginary roots, minimum number of imaginary roots. Okay, so first task is to find out the number of positive real roots. Next task is to find out number of negative real roots. Okay, now let us start. If you look at the change in f of x, you change the signs. If you take signs are plus, minus, plus, plus, plus. These are the signs of the terms. So how the change is observed here? Plus 2 minus, there is one change. Minus 2 plus, that is second change. After that everything is positive. No change in the sign. It means what you can say 1 comma 2. As there are 2 changes in the signs for f of x, there are at most 2 positive real roots. Okay, there are at most 2. Next, if you take f of minus x, if you find out, what do you get? X power 6 plus 3x power 5 minus 4x cube plus 3x square plus 4 is equal to 0. What is f of minus x? Wherever there is x, write minus x in place of that. What are the signs here? This is plus, plus, minus, plus, plus. If you look at the changes, plus 2 plus no change, plus 2 minus there is one change, minus 2 plus there is another change, second change. So plus 2 plus there is no change. So here also there are 2 changes in signs. Therefore, there are at most 2 negative real roots. This is very important. For f of x, sign changes, if you observe, you get positive real roots at most. For the f of minus x, if you observe the sign changes, that gives you at most negative real roots. So we have at most 2 positive real roots, similarly at most 2 negative real roots. So what is the minimum number of complex roots? Minimum number of complex roots is very simple. What is the degree of this equation? 6. 6 minus of, see here, it is 2 here, it is 2 here, 2 plus 2. 6 minus 2 plus 2. What is that? 6 minus 4, that is 2. So there are at least or minimum 2 complex roots for this. So at least or minimum 2 complex roots. That is nothing but the second option. Okay. Now we will move to the next question. The number of positive roots of x power 6 minus x power 5 minus 10x plus 7 is equal to 0 is at most. Here was a number of positive roots, so he is asking at most or maximum. Okay. Now let us in solution. Let f of x, that is equal to x power 6 minus x power 5 minus 10x plus 7 is 0. As he is asking positive roots, we can observe the sign changes in the given f of x. That is nothing but plus, minus, minus, plus. So how the change is observed here? Plus 2 minus, there is one change, first change. Minus 2 minus, there is no change. But minus 2 plus again there is a change, second change. So there are 2 changes. So there are at most 2 positive real roots. That is nothing but the second option. Okay. Now we will move to the next question. The nature of roots. Nature of roots in the sense, how many real roots we have, how many complex roots we have. That's what he is asking us. Now if you look at that, we will take it as fx. Fx is 2x power 7 minus x power 4 plus 4x cubed minus 5 is equal to 2. Let us observe the sign changes in f of x. What are they? It is plus, it is minus, it is plus, it is minus. If you observe here, plus 2 minus, there is one change. Minus 2 plus, there is second change. Plus 2 minus, that is third change. There are 3 changes. Okay, so there are at most 3 positive real roots. 3 positive real roots. Positive real roots are 3 in number. At most, that too. At most 3. Next, let us take f of minus x. What is f of minus x for us? Minus 2x power 7 minus x power 4 minus 4x cubed minus 5 is equal to 0. See the signs minus, 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 minus. There is no change in the sign at all. It means the maximum number of negative real roots is 0 here. Okay. Therefore, the minimum number of imaginary roots is equal to, what is the degree of this equation? 7 minus, only here we have positive roots, 7 minus, that is 4. So there are 4 minimum complex roots, 3 maximum positive real roots. There is no possibility of having negative real roots here. So in this case, if you see no negative real roots, that is correct answer. At most 3 real roots, yes, that is correct answer. At most 4 imaginary. At most is not correct. At most is tricky over here. Based on at most, we have to cancel this. This is not possible. Of course, 4 is correct only, but at most is wrong word. At least 4 imaginary roots is the right answer for us. Whenever you are saying about imaginary roots, we have to use the word minimum or at least. Whenever you are talking about positive real roots or negative real roots, in fact real roots, we have to say at most or maximum. Okay, that is the end of this assignment. Thank you. Have a great day.